Hi friends, today we are going to discuss about electric field intensity at the axis of a charged circular loop. For that, assume that this is our circular loop and the radius of this particular circular loop is, let's say, A. A is the radius of that circular loop. It is positively charged and the charge of this circular loop is Q. Our task is to find out the electric field intensity at the axis of the circular loop. That means consider this as a circular loop, then this is the axis. Therefore, if we are having a circular loop like this, assume that this is the axis. The distance from center to the axial point, let me call it as x. Okay. Then our task is to find out the electric field intensity over here. For that, let's initially take a small segment of this circular loop at the upper point and small segment as dl. That dl segment will have a very small charge, let's say dq. That is the dl segment, it is having a very small charge. That small charge is dq. Okay. Then due to this dq charge, where there will be an electric field intensity over here. Let me draw a straight line from dq charge to that point, and this distance I am marking it as r. The electric field intensity over here, due to this dq charge, it will be directed in this direction, because if I am placing a unit positive charge over here, this dq charge will repel it. Therefore, the electric field intensity is in this direction. That electric field intensity I am marking it as dE, because the electric field intensity is due to this small dq. Therefore, we are marking it as dE. Likewise, we could consider a small segment over here also. Let's consider a small segment dl at the lower end, and that dl will have a charge of dq. The distance from this lower dq to this point, it will be also r itself. Then due to this lower dq, the electric field intensity over here, it will be directed in this direction. Let me call it as dE. This dE is due to the upper dq, and this dE is due to the lower dq. Let me call this angle as theta. Therefore, this angle should be also theta. Okay. Then over here, the upper dE, I'm going to resolve this upper dE into two mutually perpendicular components. That is, the upper dE is resolved into its corresponding horizontal component and vertical component. I could resolve this upper dE into two components. If this angle is theta, I could say this angle is also theta. Then what's this? The component which is near to the angle will be cos component. Therefore, dE cos theta. This will be dE sin theta. Likewise, we could resolve this lower dE also. The lower dE is resolved into one vertical component and one horizontal component. If this angle is theta, I could say this angle is theta. Or if this angle is theta, I could say this angle is theta, opposite angles. Therefore, if this is theta, this will be dE sin theta, and this will be dE cos theta. Then we can see a single dE can be written as dE is equal to dE sin theta plus dE cos theta. Therefore, what will be integral of dE? Integral of dE will be integral of dE sin theta plus integral of dE cos theta. What's integral of dE? Integral of dE is E. From figure, it's clear that the dE sin theta components are in the opposite direction. Therefore, integral of dE sin theta, it will get cancelled each other. Therefore, I could write integral of dE sin theta is 0. It's from figure. Therefore, no need of writing integral of d sine theta, that is 0. Therefore, I could write integral dE cos theta. From the triangle, can you see a triangle like this? From this triangle, what is the value of cos theta? Cos theta is adjacent side by hypotenuse. Therefore, it is equal to x by r. Clear? Cos theta is x by r. Then, what is dE? In order to say what is dE, let's recall the electric field intensity's expression for a point charge. The electric field intensity's expression for a point charge was kq by r square. You might have learned in your previous class and all, E is kq by r square or 1 by 4 pi epsilon 0 q by r square. Therefore, what is dE? dE will be k. What is q? Instead of q, we have to write dq divided by r square. Clear? Then, I'm changing this dq. For changing the dq, let's write what is linear charge density. Linear charge density is charge per unit length, or I could write dq by dl. Can I? Then what is dq? dq should be lambda dl. Therefore, I could rewrite this expression like this, that is k lambda dl divided by r square. What? d. Substituting this cos theta and dE in this equation, we could write E is equal to integral of, what's d? d is k lambda dl by r square. Therefore, k lambda dl by r square. What is cos theta? Cos theta is x by r. Therefore, x by r. We could take constants out of this integration. Then we will get E is equal to k constant, lambda constant, x is also constant, r square into r is r cube. It can be taken out since it is a constant. The remaining is integral of dl. What's integral of dl? dl is the small length element of this circular loop. The radius of circular loop is a. Therefore, integral of dl will be total length of that circular loop. The total length of the circular loop will be 2 pi a. Therefore, I'm writing it over here. Integral of dl is 2 pi a. Clear? Therefore, we could write k lambda x divided by r cube into 2 pi a. That's our one expression for electric field intensity. Then, in order to transform this equation, let's modify this lambda. Can you see this lambda? I'm modifying the lambda. Lambda is dq by dl, or it can be written as total charge by total length. What's total charge? The total charge of the loop is q. Yep, mentioned earlier. What's the total length of this loop? Total length of the loop, that is 2 pi a. Therefore, lambda is equal to q by 2 pi a. Let's substitute the value of lambda over here. Then I'll write like this, that is E is equal to k x by r cube into 2 pi a. Instead of lambda, q by 2 pi a. The 2 pi a and 2 pi a will get cancelled. Then we'll get the expression for E as k qx divided by r cube. This is the expression for electric field intensity. And if you are substituting for r cube from this triangle by using Pythagoras theorem, hypotenuse square is equal to base square plus altitude square, we could write r is equal to root of what? A square plus x square. That means r cube is equal to, I could write k qx divided by r cube is the cube of this. This is a square plus x square root in the cube. That means a square plus x square whole to the power 3 by 2. That is another expression for electric field intensity at the axis of a charged conductor. What is K? K is 1 by 4 pi epsilon 0, or its value is 9 into 10 raised to 9. X is the axial distance, or the distance from center of the circular loop to the axial point. What is A? A is the radius of the circular loop. Q is the total charge of this loop. That is the expression for electric field intensity. density at the axis.